Welcome to Across the Globe. Today we will learn about recursion in Python. Recursion is a programming technique that involves a function calling itself to solve a problem, breaking down complex problems into simpler subproblems and solving them recursively. The two main components of recursion are the base case, which serves as the stopping condition preventing infinite function calls, and the recursive case, where the function calls itself with modified input to progress towards the base case. For example, in calculating the factorial of a number, recursion can be utilized by defining the base case when the input is 0, and the recursive case as multiplying the input by the factorial of input minus 1 until reaching the base case. Recursion is a programming technique where a function calls itself in order to solve smaller instances of the same problem. The provided Python code demonstrates recursion by calculating the factorial of a number. In the code snippet, the function factorial n recursively calculates the factorial by multiplying the current number n with the factorial of n-1 until it reaches the base case of n equals 0, where it returns 1. For instance, when calculating factorial 5, the function expands to 5 to factorial 4, which further expands to 5 to 4 factorial 3, and so on until it reaches 5 to 4 na 3 2 to 1, resulting in the output of 120. Recursion can be a powerful tool for solving problems that can be broken down into smaller, similar subproblems. However, it is essential to ensure that the base case is defined to avoid infinite recursion and stack overflow issues. Recursion is a programming technique where a function calls itself in order to solve a problem. In the context of the Fibonacci sequence, recursion is used to calculate the value of a number in the sequence by adding the values of the two preceding numbers. This process continues until the base case is reached, which is when the function returns a specific value, 0 or 1, in the Fibonacci sequence. For example, in the code snippet provided, the function Fibonacci n recursively calculates the seventh number in the Fibonacci sequence, which is 13. Recursion in Python is like a Russian nesting doll, where each doll contains a smaller one inside it. Just like how each doll is a self-contained unit with its own smaller doll, each recursive function call in Python is a self-contained unit that calls itself with a smaller input. This nesting of function calls continues until a base case is reached, similar to how the smallest doll in the Russian nesting doll set has no doll inside it. Once the base case is reached, the program starts unwrapping the recursive calls, similar to how the dolls are taken out one by one until the original doll is reached. This process allows the program to break down a complex problem into simpler subproblems, making it easier to solve. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. Recursion in Python is a powerful concept where a function can call itself in order to solve a problem in a smaller, more manageable way. In the provided example of Russian nesting dolls, the function Russian nesting dolls takes an input size, which represents the size of the nesting doll. The function first checks if the size is equal to 1, which serves as the base case for the recursion. If the base case is met, the function prints smallest doll reached. If the size is greater than 1, it prints doll of size contains a smaller doll inside, and then recursively calls itself with size-1 as the input. This recursive call continues until the base case is reached. Once the base case is met, the function begins unwrapping the dolls by printing unwrapping doll of size. This unwrapping process happens in reverse order of the recursive calls, starting from the smallest doll up to the original starting size. Real-world applications of recursion in Python include tree traversal, e.g., depth-first search, factorial calculations, Fibonacci sequence generation, and more. By understanding the principles of recursion, programmers can solve complex problems in a more elegant and efficient manner. An industrial application of recursion in Python can be seen in file system traversal. When a program needs to traverse a directory structure to search for specific files or perform operations on files within directories, recursion can be a powerful tool. Another real-world application of recursion in Python is in web scraping. Web scraping involves extracting data from websites, and recursion can be used to navigate through nested HTML structures or multiple linked pages to collect the desired information. Recursion can make the implementation of these tasks more elegant and concise by handling complex nested structures effectively. Across the globe, the versatility and power of recursion in Python allow developers to tackle intricate problems and tasks with ease and efficiency. Keep learning, stay curious, and I'll catch you in the next video.